Oh. Hello, hello, hello. I just realized I was I was streaming, but I didn't push the go live button, so I was talking by myself. So hey, 42. I think I was replying to your comments, but then also realized that nobody was listening because I didn't push the go live button. So I guess I'll have to recap what happened. So I'm gonna go back in time a little bit. Also because I want to change route. And I was about to re-enable multi-threading, but really what I want to do is to optimize the bandwidth usage. Let's see if rolling that back is enough. So right now it is being generated, and that is that's working. But the whole data is being uploaded to the GPU every time, which is not ideal. And it's a lot of time wasted in synchronization, because we are at this point bound by the transfer bandwidth. Instead, we need to migrate to a different model. The previous model, where we only updated the current chunk, the chunks that were updated, and that was working correctly. It was a bit overly complicated because of the buffers handling inside the shader class directly. But yeah, we can fix that. So once the chunks are generated, so we begin with the generate chunks function, and this will get some chunks, okay. And then it says what? Chunk updates. Hey, Gandab, how are you doing? Yeah. This is a texture that I made, well, that my son made yesterday. So I scanned it, I cropped it, and then I used it. It was pretty happy to see it happen. I spent a whole day making textures. I've got all of them here. Like, it's got blocks of every type. I don't know if you can see it. It worked really hard on it. So I'm gonna use it. I don't know what this is, but yeah. There's also, what is this? We got water. I'm gonna use water at some point. Because now the water is all turning green. And yeah, the only thing that is missing is the ambient occlusion between blocks. But I will tackle that as soon as I optimize the generation. Then we can go after rendering. So one of these empty areas are supposed to be going down, you see? So this is a deep area, and it should be covered by layers of water. But instead it's all green. Yeah, that's fine for now. So the textures are, let's see, the textures are handled here. It's pretty basic. So my goal is to support bindless textures. Are you planning on using that to reduce the draw calls or other form of polling? Yeah, I was talking about this now. I mean, they're all very low res, so I don't think I'm gonna need a lot of bindings, and I can fit a good amount of textures in one single texture. So I'm planning to have something like this, where I can pick parts depending on where they are laid out. Yeah, it might be a bit hard to do any artistry thing, but yeah. I will make this bigger and bigger as more blocks grows in here. But yeah, let's see. Things can change. Like even, yeah, bindless. Well, actually, bindless. So do they both support it? I don't remember. I'm gonna open my big reference, which is Quest 2 versus Quest 3. This is my way to go and check extensions. So Quest 2 doesn't have bindless. Oh, nor Quest 3. No, they don't have bindless. It's definitely something in my computer. So in the extensions. Oh, wait. Is it a feature? No, not even that. How is it called? Oh, weird. Bindless textures. Is it core or something? Descriptor indexing. Oh, okay. It's yeah, descriptor indexing is okay, but it's not bindless. I think there was a bindless rendering. Yeah, there are so many extensions. I don't remember if that was an OpenGL thing, bindless texturing. So yeah, descriptor indexing, it is, but descriptor indexing, yeah, I think I did that. I did that and then I simplified it way. So descriptor indexing it is, yeah, but not using it right now because it's very simple. So the descriptor indexing, I was using it for the chunks. 1 minute. Oh, you remade it, great. Yeah, I remember you had the power and the files loss issue. So I'm trying to think of where the descriptor indexing would be useful. Because right now I'm using a single descriptor and then I'm indexing it through the object draw index, and then basically using fixed size pool memory. So that's going to be a pool memory for all of these things, and then I will use, let's see, yeah, I will update only the ones that I need to reuse. I think that could also work. Because otherwise, yeah, the textures and shader and access that texture. So I think the way bindless textures are typically implemented in Vulkan is that you create a massive array of textures, descriptors. You don't have to use all indices and just have the index associated with it. Okay, yeah. Texture in the shader and access the texture. Yeah, but then there is there's then the whole binding thing and the pipeline layout, which is gonna make everything much more complicated. I have a single shader right now, so everything is very simple, and I would like to try to keep it that way. So that might be something for the future. I don't want to stress out too much about the performance if it's good enough. Let's see. I wasted so much time trying to figure out the glitches, and in the end it was just because of a missing barrier. So I didn't place a barrier here between the copy and the usage of the indirect buffer, and so that made everything flicker, and it was not reproducible in RenderDoc because it wasn't able to capture the data race. So that was just madness. Yeah, I have to remember about barriers more often. Okay, so how do we move forward here? So first of all, let's not generate this every time. Yeah, I've actually dealt with that exact barrier issue too. Deep within Unreal Engine was very hard to debug. Yeah, especially when there is a big boy like Unreal Engine underneath, lots of code. The good thing is that when you have to debug it on PC, that's simpler. The nightmare is when you need to debug it on a device. I had to debug things on the Quest in Unreal Engine. That is just complete madness. So if the chunks is empty, or the distance have moved, then let's do the generation. Otherwise, we can just skip it over. Move that. Don't need that anymore. Let's see, this should already only generate when it's moving. Yeah, I can already feel that there are little hiccups. That's supposed to happen. But I also want to check. Wait, let's see. Generate. Okay, this will only generate. But then the update is gonna run anyway, while it shouldn't. So the update also will depend on the generation. Let's do something very fun. And let's say return false. We're gonna turn this into no discard bool. And then when generation happened, we return true, meaning that in the update function, we will check if generate function. Well, let's see. Const bool needs update. And if it needs update, that's very verbose. But it makes it much more readable. Let's see if this works at all. Okay. What? Something happened here. So we are getting errors. So something Something is missing. Object descriptor set. Well, that should stay fixed. There are so many. So where does it begin at? Bind descriptor set parameters. Bind invalid VK descriptor set object. Descriptor set 1. Why is that? Because if I'm not running this, it doesn't do the writes. Okay. Since the descriptor pool gets reset, it needs to do the write. And maybe I can refactor this in a way that the write always happens. I don't think the write needs to stay here, but yes, it does. Also, the buffer is also freed, so that's not good. That is definitely not good. So freeing the buffer should not happen here. It was fine for these short-lived buffers because I plan to have them deallocated every time. But yeah. Okay. So the buffer needs to be moved somewhere else. Hey, welcome back, Sibi. Let's see. How can I set this up? So maybe this whole thing can should be discarded once it's done. So it's kind of a frame thing. I can set it as like when I do the update chunks, and I could say I don't know, chunk state something. Yeah, let's try to call it chunk state or chunk frame. I don't know, chunk frame. So that's going to be another struct, chunks state. So I need to capture the state of the chunks at this moment. And that will be returned from here. I have no chunks. Well, that shouldn't happen anyway. No chunks generated. Well, chunk state is gonna be empty. Yes. Damn it. So chunk state, I'm gonna call it state. And this will return state as soon as possible. That's it. In a very default state. Then chunk state will have maybe a draw count. Yeah, let's move the draw count into the chunk state. Chunk updates. It's gonna have copy buffers. Let's see, copy buffers and delete buffers as well. Vertex buffer offset. Well, definitely vertex buffer offset. And then the descriptor sets. No, maybe not. Not the descriptor sets. Ah, the descriptor sets. They will be valid for this frame. Let's start with a draw count. Draw count. Well, actually, yeah, let's shrink the scope down a bit. So instead of starting refactoring everything, I will just target what needs to be done. So what do we need from here? Count, everything is fine. I need to delete these buffers, but later, not now. And also I need to keep track of these offsets. Not that there are many, to be honest. Okay, that's okay, so this is a snap. So I need a snapshot of the delete buffers. So chunk state will have delete buffers. Delete buffers. The staging can go as quick as possible. Yeah. The staging can go. So only the vertex buffer remains. And same here, the object buffers. The indirect buffer too, because that's what's going to hold args buffer offset. So yeah, we have the offset, and this offset can be moved. Yeah, it shouldn't have been. Yeah, so I'm using the offset, and yeah, okay, so it makes sense. Offset also will be moved there. Well, do I really need this? Like in place, I don't really need to do this. Not really. Because I can just store the sub allocation. Yeah. Doesn't really make sense to have it like this. Okay, so instead of storing, I get it now. So instead of storing the buffer for deletion, I will just say that vk buffer suballocation. So we have the vertex buffer, then we have the uniform buffer, and then we have the arguments buffer. That's it. So there's no need to delay, just to destroy whatever was previously set. Also the arguments offset and the vertex offset can be included. I mean, they are included because they literally there. Okay, so then chunks state, that's gonna be chunks state. So this one, we already have it. And this one doesn't need to happen. When we create a new state, well, we don't need another state, do we? Have a single state. So we can say if chunks state dot vertex buffer, if it does exist, well, it of course does, but if it has an allocation, okay, and it's valid, then we dispose it like it was before. We dispose it with, okay, by sending it to there, and the same with all the other buffers. chunk state. Then we have the uniform buffer, delete buffers, and that's going to be, what is it called? Frame buffer, object buffer. And the args buffer. Args buffer. Well, that's it. This should return true, meaning that we have updated. I'm not sure if it's needed. It's probably not needed. Well, it's not return true, but return false. So we have not updated. Maybe. Well, we have updated anyway, because we deleted stuff. So yeah, let's keep it void. There's nothing to return from the here. Then this can go. We just need to remember suballocations. So that's going to be chunks state dot vertex buffer. And what's the problem? Buffer suballocation. So yeah, it needs the value. Should we check? Yeah, we should probably check. So auto destination SB. If the destination SB is valid, then we do well, this needs to be deleted anyway, and maybe even the copy needs to happen only if the destination is valid. And then we do the copy buffers, and then we set it to be a destination. The value, okay. Don't need that anymore. This can be const. This can also be const. So same here. Check if it does exist. Then if it exists, suballocation, move all the thing in, and then this will be moved to object buffer, chunk state uniform buffer. Okay, that's what needed. And the allocation. So the allocation is already set. And this we can move it out of the box. And it can happen here, where we allocate, we set, and then the object buffer, we get it from the chunk state dot uniform buffer dot offset. That's it. So last bit here. You don't need to do the check like this because this is very implicit. Vertex, arcs, buffer offset. We don't need that anymore. Delete it. And we'll do the same. If suballocation exists, then remove the copy, and we need to set the destination to the args buffer. Delete, and that's it. Here we have the state, chunk state, args buffer offset. And here, vertex buffer, chunk state, vertex buffer, offset. What else is missing? And the args offset, chunk state, args buffer, offset. Well, that's everything. Let's make it a run. Okay. Nice, it's working without errors. That's good. Ooh. No, wait. We're missing something. No, we're not. We forgot something. That is probably, yeah, the disposal. This disposal, it only happens. It only happens here, which means that by the time I close the application, this may not run, and this will stall. So to avoid that, maybe I can close this into clear function. Could be. No, it cannot be. Clear, because this is going to add it to a buffer. So that is internal. But I can call it clear chunks state. Chunks, clear chunks state. That is void clear chunks state. It's no accept, and it does what is meant to. It needs frame context. Not really, not the frame context. It just needs timeline in 64T timeline value. Okay, and that does it. The timeline value is going to come from the frame. Then we can come over here before calling the garbage collection and clear the value at timeline 0. So it doesn't really matter because this is gonna garbage collect first. Hey Yosh, what's new version? What's that new version of CPP? This is CPP 20-ish. Yeah, I'm using some ranges. It's not the new version. It's just I'm just using C++ 20 modules. So this is how I set up my project. I have the main per platform files here, which is mostly the Windows main. And the Windows main is very simple. There is Windows context where it creates all the Windows stuff. So there are different modules. So this is very normal Win32 stuff. I just wrapped it into a container class. Yeah, nothing fancy here. It just creates all of these objects that are contained into modules. So this is the Vulkan module. This is the XR module. So it's just a different way of writing code, really. I mean, it's C++ 20 modules. So you declare the module. You declare everything that you don't want to be in the module. So this is just used for compilation. This is the private module fragment. And then you declare a new module fragment where you actually have things that you want to be exported and defined. So I'm gonna export a namespace, which is Choppy Engine XR namespace, where there is all the context and everything is exported in the namespace. Then down here, I'm gonna declare an import. Well, first this is the application module. So declare the application module and all the different modules that is going to import. Oh boy. Oh, and I'll sneeze. Hope it doesn't sound very boomy. So yeah, this is it, right? These are the platforms. So everything is modules. It's probably not the best use of modules so far because I have implementation and interface in the same file, which is making compilations a bit longer than I really wanted. So I will have to split implementation and interface. Yeah, that's it. Nothing fancy happening. Just regular C++. And the compiled code, the compiled game looks like this. I can even use the gamepad. Yeah, I like it more when I'm doing this flyover. Oh, it's glitching a lot. No, I mean, it's not glitching, it's just... Oh, wrong direction. Trying to do a flight mode. Ah, I get the Y direction wrong. Because I'm thinking like an airplane. So I push down to go downwards. Whoop. Ah. It is pretty fun. I like it. I even have implemented the booster. So if I press the right trigger, it's gonna boost. Ooh, we enter warp mode. Entering warp speed. It's not fast enough. Faster, faster, faster. Whoa. Okay. Well, it's pretty solid. I mean, it's generating an infinite world, so nothing fancy is gonna happen. Oh, I'm catching with that generation. It's going crazy. Let's see from the top. So this is the current size of the world. I could probably go a bit bigger than this. Okay. It is, yeah, it's a bit boring though. I will add more blocks later. And this is still run in debug mode, so in release mode it's gonna be blazing fast. But I want to optimize it in debug mode. So things should always run in debug mode. I don't like when something is supposed to only be compiled in release mode, because otherwise it's gonna collapse in debug mode. Okay. So the generation now only happens on demand. Let's see how this runs on the Quest. I hope it's gonna hit a good frame rate. Otherwise it will be disappointing. Oh, no devices. I need to turn this on. Come on. Okay, it's coming. It's a sunny day today. I like it. It's rained a lot tonight, but I like the rain. Well, I mean, I like the sound of the rain. I often put sound of the rain. So there is a pretty nice rainy mood. This is my way to go. And then there is also noisely. What is it called? Noise. No. What did I write? Background noise. Oh yeah, this one. My noise. Okay. It's got a pretty good selection. Yeah, these are pretty chill vibes. And it's not just I like it because it's not just like waves, brain waves or whatever they are supposed to imitate, but they also have some musicality, some taste. The waterfall sounds from the Middle East, sounds from, I don't know, from the north, this kind of stuff. Senegal town. Yeah, I'm gonna try that. Marimbas. Fireworks. No thanks. Oh, pet comfort. Really? Pet comfort? Help your pet adjust fireworks. Oh, okay. This is trying to teach them. So facial tones. So is it building? It's ready. Let's go building. Let's see. It's building. What's wrong? Thread. We don't need this. So you can go. Oh yeah, because I think I removed the include, which wasn't used. It was grayed out. Without realizing it wasn't used because I just commented out. Okay, so far so good. It's taking a bit too long. It's taking way too long. What's happening? Okay, that's taking too long. It's too long to be something. I received note from OCMS pack. What? Okay, loaded. I think it was just no. What is this? Weird. Stop. Okay. Let's stop. We go to let me try to do it directly inside. Run. And we wait. Huh. That's crazy. What's happening? What's going on? Let's give a look at the log. So clear out the logs. Make them bigger. This is loaded. This is loaded. Image is loaded. Everything is doing its best. XR state, synchronized, visible, and then focused. Use hertz interstitial, whatever is that. We are in focused. Okay, that's cool. Okay, I know. Let me bring a PowerShell up, and then I can do an inject. So we enable Vulkan layer, and we start it again. And nothing really happens. I am going to restart. Restart device. You never know. I might just fix the issue. I mean, doesn't really make sense. I haven't changed a lot of things. And let's go. Let me try to see if it starts by itself. Hey. So black. Why is it all dark? Stop. Oh, because I'm in release. No, do the debug mode. That's why I wasn't getting any feedback. Let's try debug first. Let's go. Okay. We getting a crash. Well, that's better than nothing. So we are getting a crash, and that is happening at generate chunks. Okay. Vec3. Interesting. Let's go debug. I mean, why would it happen only here? Is it gonna happen in VR? Maybe it's happening in VR. So let's head over to the simulator. Come on, mouse. Simulator and start. It is working here, so no problems. Okay, so it's not a problem with the VR mode. What's happening? Nothing. Okay. Let's go debug again. Debug mode. Okay, it's waiting. It's running. It should break at any point. Okay. So first generate chunks. Number player. So what is it bothering you? Distance is... Huh? Ooh. This. This doesn't sound good. What is? Where is this coming from? So there's a main loop. Context. Yeah, we do have a context. And there's the Android app. Okay. Context exists. Then the app does exist. It is doing a tick, and then the tick does the present, and then the present is run right away. Yes, update. It does the update, callback. This is the update, callback, yes. Update, callback. Okay, it reaches here. Then we go to update, and we have a frame. Yes, we do have a frame. Then we go to generate chunks, and we don't have a frame anymore. What? Why? Solid flat. So we do have this. Then generate chunks doesn't. Selecting word. M player. How can that be? What's wrong? Something is messing with the stack. But this is the first line. Why there's always something new? Fixed frame, view. So here we are referencing correctly. Translate. This is so weird. VK utils frame context. Oh man. Ugh. Um, Controlling your VR headset with your PC, like how would you connect it? This is just using the MetaQuest Developer Hub. So once you get installed, you can find it on the Meta, and then you need to enable the developer mode. But to do that, you'll need to use the mobile app. So once you have that enabled, you can plug it into your computer. It will pop up. Would you like to connect to as a developer mode? You say that, yes, and then you can see it here. Once you see it here, there's a cast device button. It will connect, but I already have it, so I don't think it's gonna let me connect twice. But okay, it closes both. This is just a shortcut because this is gonna launch an executable, and what I did is just I created a link to the executable by myself, and so I can just run it like this without even needing the developer hub. So I can do it quickly. The caveat is that you can't have multiple devices connected. This is very unfortunate. So this exists here. Then it doesn't exist here anymore. Does it exist? Up. Back 3. This stuff is just math. I mean, it should not. Okay, let's do something. Reset descriptor. Is it reset? I mean, reset descriptor could be the one that screws up. Reset descriptor. Present index. Let's see. Because why not? Let's go debug. It's taking super long. Okay. No? Didn't make it. Okay. Error. No problem. We can try again. I'm gonna close this so it doesn't interfere. And try again. Okay, we are getting there. So fine, reset descriptors. Let's go inside. Descriptor pools. Hey, wait. This. So the pool index is 1. Descriptor pools is 3. Okay, so it does exist. It's also allocated. Right, and clear. Okay, they are both cleared. Okay, this was successful. Then we go in the function. We have this. It's doing correctly now. So this was the first time. And now, what happened? What? It was supposed to stop there. So generate chunks. Why does it run again? This is odd. Generate chunks. No, the thread is not working. Generate chunks. Is it running twice? Generate chunks. Okay, just running there. So it's not like there's other places. Why does it say 3? Okay, yeah. That's the right amount of count. Let's do it again. Hey, stop. Okay, it's gonna stop there. Then we jump over and aha. So it's down below. It's not right here. It is down below. It's probably crashing at return. Well, and instead of doing the right return, it's probably re-entering the function. Let's see. Let's go inside. This is all good. So it does its thing. Do we have return at the end? Yeah, we do have return. No return. Wait, did I say no return? Oh no. I said no return, but it should have been no discard. Could it be that? It could be that. It could be that. Nah, it can't be that. So I'm gonna keep debugging. Yeah, saw it before I did. Oh, has Bob Ross risen from the grave? Why is it coding? Hey, God of Toilets. Well, that's a bold name. Bob Ross AI, if you haven't realized. Let's see if no return is all it takes to screw up. The stack. I mean, let's go up. And yeah, that was it. Really. That was it. Yep. I did it. No return. Wow, it took it seriously. I thought it was some sort of hint. It really took it seriously. And I didn't see any warning, but maybe because I've ignored it. Let's see if I do a silly change and then a recompile. Will it tell me that that is dumb? Wait, what? Follow current saving file. Unable to open file for writing. Really? Who? Why? Don't screw up with my code. So try to rebuild it. What? No, nothing to rebuild. Okay, now you're building something. Can you maybe show me what you're doing? Wrong. What is tell me? Ignoring return value of a function declared no discard. Okay, that's fine. But let's do it again. No return. Are you going to tell me that I'm doing something dumb? Let's see. Maybe I just ignored it. Declared no return should not return. Should not return. Okay. Yeah, that was actually there. It even told me twice. Why twice though? Generate chunks. Okay, because of the two return values. Well, no discard. Okay. Let's say we fix it then. Time to switch to Rust. Well, that's gonna take me longer. I mean, at the end of the day, I did something dumb, and the compiler did warn me, so I don't think there is anything wrong. If you ignore the compiler, then you are already leading yourself in the path to hell. That's why I'm trying to keep myself kind of warnings free, and also you can switch to Rust and still ignore Vulkan warnings, so that's not gonna save you anyway, unless there is a safe version of graphics programming, which is OpenGL, by the way. I don't know why people don't like OpenGL because it's too old, but that's basically Rust. Okay, the performance is awful. I was hoping for better, but probably. Why is it that this slow? So it's not hitting the 120 that I would have loved. And I'm not sure if it's because of the geometry. Can't be. Yeah, I can definitely see the when new chunks are loaded in. That's fine. I don't mind that. We can fix it with multi-threading. But let's see what happens if I switch to release. But web GPU is a safe graphics API, right? But it's not. It's not at feature parity with Vulkan, and it has a lot of overhead. Yeah, that's what OpenGL was. Also, web GPU is web. So kind of feels like if you want safety, then if you do it in a browser, then you are definitely safe. So it feels a bit at the same level. Wait, what's happening? Okay, it is working now. This is release. Let's see. 3 viewers, so yeah, I guess you're still there. Yeah, no worries. I mean, you don't have to talk uh, in a forced way, so people should be free to say when they need to say something. Okay, okay, okay. Huh, still very slow. Okay. This is too slow. So there must be something that I'm still doing, and it shouldn't. So what is that still happening? This is fine. Is it the descriptors? Descriptor sets? Can it be that costly? It shouldn't. But still, it was working better when everything was fixed. Let's see. Time to open RenderDoc. Maybe RenderDoc requires a debug build. So let's give it one. Yeah, I mean, it's not throwing in a crazy amount of stuff. Could be the push. Well, no, that can't be because shaders optimized away anyway. Okay, so yeah, I just want to see what is happening with RenderDoc. No, not this one. Meta. Let's launch. Invalid. Okay, because we don't have a context. So shader. Yeah, I can just switch this and do a build. Yeah, push constants. I have this push constant, so but it's not used, and it's likely removed anyway. Did it do the build? I need to build multiple times because of how CMake is run after the assets have been packaged. So to make sure that it's picking the latest shader build, I have to run it multiple times. Yeah, lucky I'm not using it anymore. Okay, so here we are back. Yeah, it doesn't make any difference really. But maybe I can. So if I go back to the update, so if this needs to be updated, I can make this a bit bigger and say that needs update only runs. Yeah, if it doesn't need update, then we just ignore. And everything else remains fixed. That could be an improvement. Well, it's not gonna update. It's not going to update the camera, but okay, no problem. I just want to see if it runs. Yeah, it's not updating the camera, and still really bad. So it's not about the descriptors. Okay. Let's go back and rebuild it. Okay, it's back to normal. Now let's do a capture. Yeah, always better to profile. All right, let's do a capture frame. Hello, Chichi. Let's capture one frame.
Did you change it back?
No,
Or is it the old one?
no, I'm just testing.
The old one?
Yes. Yeah, he has arrived. Let's see. We have 600 objects, like 600 chunks. I don't know if that's too much. Is there a trick using to be able to capture with RenderDuck natively on Quest? Not really. I mean, you have to download the metafork. Are you using that? Because the normal RenderDuck doesn't work with a Quest specifically. And if you're using that, then it should be out of the box. So only one copy is happening to the per frame. That's it's fine. So we do the barrier and set the viewport, find the vertex buffer, find the descriptor set. Yeah, nothing else happens. So I wonder why is it so slow? Get semaphore counter value. This can't be that slow, can it? Wait for semaphore 1317. No, I think they made it in a way um, because this is going to install a few things on the device. Maybe they've also have their own because if you look at the installed applications, then you have the the render doc command, and you need to enable a bunch of things on the device. If you look at the diagnostics, then you can see that it runs a fair amount of ADB code, ADB commands. You see, it needs to enable lots of things. There might be something that is specific to the quest. What is this? Unknown. Could not find image for Vulkan image. Huh. Cool. Are you working on just the engine or you're doing a game as well? See you 42x. Good night. I don't know, really. Coherent map write. Okay, this is a lot of coherent mapped memory write. Why is it writing this whole amount of memory? Where is it coming from? So we do the update descriptor set. Q submit command. Which command is this? Oh, I see. Yeah, when you're working with an engine, with a game engine, that is specifically designed for type of games and type of quality, then it's hard to get out of the constraints, right? You have a lot of freedom, but that's at the same time very hard constraints, especially if you are running on low-end devices like a VR. If you think about it, you are aiming at something like 200 frames per second on a mobile. So this could be fine. I'm just not really... This is very suspicious. So there is a mapped range, and the size is huge. What is the memory? Memory 140, staging buffer. Yeah, mobile. I mean, unless you are targeting like the latest and greatest iPhone or any other device, like which is more than 1K. That's just ridiculous. It would be the pipeline barrier. Let's just for fun. Let's see what happens if I remove the barrier. I'm open to any solution at this point. Debug. Maybe I want to run. No, it doesn't make much of a difference if it's debug or release. Okay, where are the performance? Still really bad, so it's not the pipeline barrier. Wait, how many triangles are we drawing? Right? How many polygons are we actually drawing? So we have this, and it's got a few thousands. Some are very small, some are big. Maybe I should count them. Right now, I thought I'm actually working on some improvements for my own async runtime job system to allow custom allocators. You mean on CPU side or resource management? I assume you're working in Rust, right? So the pipeline barrier is not. Yeah, I don't think I'm still. I don't have a personal take on Rust. It's just, yeah, I'm not ready to jump ship. There are other languages, and if it was the only one, then I would say, okay, that's it. We got new language. Then I'm not. I don't want to change again and again. There's Zig. There is J. There is, what are they called? The other ones. Odin. I don't know. There's so many. Like, I don't want to waste time trying compilers. I don't care. Is it unsafe? Whatever. I think I'm just getting better nowadays. It's not like I'm concerned of anyone hacking into my my application. I guess when I reach the point where I'm doing some multiplayer and some service things, I'll jump into something else. I don't want to do any critical section of my code. So it makes sense for security reasons, but I don't think there is any security related to the game. So it's like whatever. There are bits of the games that need to be safe, that's for sure, but not the game itself. Especially not the render. Wait, what was I doing? I was looking at, oh yeah, the draw count. So what is the draw count? I'm quite curious because it doesn't make sense to try optimize something that is not optimizable. Well, maybe the render is just fine. Timeline value. So, wait, why is it never used? Oh dear. No, it should be used. Nothing. Just because this is yeah. Android Studio can't do IntelliSense. Oh, code completion. Yeah, I keep calling it IntelliSense, but should be called code completion. So what was I doing? Yeah, counting the amount of things that needs to be drawn. I think I can do it in the update chunks. Okay, draw count. Salute. View. This might be a big number. And 32. I should fit. All is. And that is 0. So for each chunk, for each mesh, append range, vertices, that's going to be I. What's your opinion on TAA in Unreal Engine 5? TAA in Unreal Engine 5. Yeah, I guess it's fine. I don't know. I don't have a strong take on that. For VR, if you mean for VR, well, then maybe it's not the greatest choice. So yeah, the best would be MSAA, I would say. But it's pretty expensive, and TAA, yeah, I would say it's more of an artistic choice, and which has to be balanced with performance budget. So the safety is nice, but it's not the main appeal for me. Rust have nice value semantics, and it's more convenient to write normal code with less edge cases and gotchas. However, C++ is just way easier to just jot down code and think about architecture later, which is a pro. Yeah, I mean, architecture is a double-edged knife, because it's very easy to overdo it. Like sometimes I just want to get things done, and that's most of the time really. You just want to get things done, and I've met people that really overthink, and they end up with 200 classes that most of them do nothing, like they just exist, and that is crazy. Like you need to split the code when you start needing it to happen, like I just did. Like I felt like this stuff was good to have it in a container because it makes logically sense. Yeah, that's it. It's not like there is much about it. It sure gets in a weird state when you start thinking about okay, what's the what happens to the vertex when it gets copied, and yeah, I guess I think to learn more on allocation. Like what you miss is the opportunity to really think about the memory layout, which is something that Zig does very well, and you don't really think about it. But I think that if I were to dump all the allocation that is happening in this very small application, then it would be surprisingly high number of allocations.
You look at all of these are parked cars.
Uh-huh.
And there's a parking station from here. Look, from here to here.
Oh, from the end to the from the tail to the head.
Yes.
So how many polys are we drawing? So at the end, I want to log drawing vertices. Yeah, I called it poly, but then it's vertices. So I'll say polys divided by 3. Oh, okay. Didn't know that. Cool.
What?
Polys. Let's see how many polys we have. Amazing, Tracy.
From this gray car, I put one more gray
Oh
car.
yeah.
I put one more gray car from here to there.
Mm-hmm.
Is that our old one?
Yes, this is the old one. So how many polys? This is rendering.
It's
okay.
the old one meshed.
It's not that many. I thought it was much more. So it shouldn't be a problem rendering them. No, not yet.
When is that you're done?
Later.
Okay. The second one I will be inside.
Okay.
But do quick with this video.
Mm-hmm.
Because I think you drank coffee today.
How do you know?
Because yesterday you did that.
You got me again.
If I got you, do it for a little bit more.
Okay.
I'll put the timer.
Yeah, I think I'm almost done. No need to put the timer.
You have 1 minute.
Okay. 1 minute left. And then I will stop the stream.
And then I come inside.
I come inside. But I am done anyway. Okay. we do something else today.
And now I'll...
No, you don't need to. I'm almost over. So how many polys is it doing? Okay, yeah, it's 100,000. It's not that much. Yeah, it definitely shouldn't struggle. So it is not about. Yeah, that's true. TAA is also for VR. It's really not that great because you may end up with different resolution with different AI anti-aliasing in different eyes. It is about 600. So how many indirect draw calls? It's 600. Yeah, it is 600. It's not even that many, is it? No, I don't have empty indirect draw calls. Like they are pruned. I mean, I can remove the ones that are very shallow. It wasn't doing that bad. Maybe it is. I don't know. What if I can higher the poly count easily? So I can say that the number of draw calls is gonna be way less, and the indirect calls, but then I can increase the resolution of each chunk. Where was it? Here. So instead of 8 by 8, I don't know, 32. Okay, so now I'm generating half million, and it so with way more poly is running at a higher frame rate, which is ridiculous. Okay, so that is the bottleneck. Which is a bummer, but it is what it is. Maybe I was doing too small chunks anyway, so 32 cubes is still a good value. So this is definitely running better. It looks alright. It's just a bit too small. I need to scale everything up. But yeah, that was it. Let me get back to this shaded version. That is this doesn't cost anything. What if I push it to 64? I'm gonna hit. Well, it's probably gonna hit more than medium, but then I can reduce the number of chunks even more. Let's bring it down to three rings. And this is running debug, so I think I can push the generation. Also, with voxels, aren't there methods to create multiple meshes for a chunk with backface removing during precomputation? Maybe you have to reduce poly. Well, this is already it's already done. What if you use a normal drawing instead of? Yeah, I don't think that will make any difference really. Okay, this is taking ages to generate now. Let's see how much it will generate. Haven't started yet. I hope it's not gonna run out of memory. Yeah, still generating. Is it even running? Oh, okay. It's back, and the performance it's not that bad. It dropped a little. So it dropped just a tiny little. Oh no, I triggered a new chunk generation. It's dead. Okay. There's just too much computation.
Now can you mine?
Hmm?
Can you mine or
Not yet mining.
but can you build?
Not yet.
Do the building thing.
Okay, let's go back to 32 by 32. I'm gonna switch to release mode because the generation is gonna get so much faster. What if you use normal? OpenGL isn't getting updated anymore, right? Well, it did update it. So we are 4.5, 4.6, and it's getting extensions. So I think it's fair to say that OpenGL. What is the current version of OpenGL? It's 4.6. Uh, 2019. Is there going to be a 4.7? Will there be new versions? Yeah, there's probably going to be a 4.7. I don't see why not. Future of OpenGL. Well, anyway, you need that amount of like advanced features. Well, at that point, it makes sense to use Vulkan if you need like the cutting edge features. But most of people are just fine with OpenGL. I think if you are doing a 2D game, if you're doing a very basic 3D game, that should be right. If you're doing a very complex 3D game, well, then maybe it's the best choice to use a game engine at that point. It doesn't make to go to do not just it doesn't make sense, but it's probably impossible to get the level of Unreal Engine. You're just gonna waste so much time. Wait, what? Oh, we dropped. So with textures, we dropped quite a bit.
This dropped.
We dropped performance. So I switched back to 32. I'm in release mode.
Why did you put the black things on top?
What are the black things?
Black things on the top of the green.
There's nothing on the top of the green.
I see some different color.
No, it's all green.
Do you see those lines?
Ah.
Those lines.
Yeah, that's the texture.
Okay, it's the thing.
And otherwise,
the end of that stream, of that video. Daddy, that's the end. It's time with me. Daddy, it's time with me.
Performance. I want my own Minecraft. Our own Minecraft.
You need some.
Lua script inside the game. Yeah, I mean, why not? That's definitely a good thing to have. Maybe not Lua, I don't know. Is people so used to Lua that it makes sense to be Lua? There are other scripting languages.
Daddy, now it's the end of this one.
You can come over and decide, but there's nothing funny happening. I'm just trying to make the performance better. What do you want to see?
I want to sit from there, not from here.
Okay, sit down here then. No, go behind.
Huh?
Go from behind. Right, sit down there.
How difficult it is.
Did you have breakfast?
Still no.
Eat a banana.
But I won't even drink water. So we do that. What the heck? Oh,
Let's
my
go have a
God.
proper breakfast, okay? Like, leave this thing.
What the? How do you go there? How much down did I go? Huh. Yeah, what the heck? I need to be careful with this thing.
Yeah. The FPS. Okay, so there is a drop in the frame rate depending on where I'm looking at. So there is definitely some overdraw happening. No. So the frame rate's going up. And then it's going down like this. Yeah, there's definitely a lot of overdraw. Yeah, that can be Skycraft then. I'm gonna make Skycraft.
Is Skycraft?
Well. That's a lot of land anyway. Also, it's how much is rendering? It's rendering a fair amount of polygons now, so
No.
does make sense to have a lot of overdraw. So we should definitely keep it down.
There's red. There's 6 red.
But overall, GG. Okay. Yeah, that's it. I guess I'm satisfied. Mixed feelings for today's stream, but you can get better. Cool.
Can I test it on the controller?
Yeah, I'm gonna do that. Bye everyone. See you next time.
Bye. Bye.
Yeah, I do have MSIA enabled, so
Booey.
maybe
gonna say that.
also that.
I was gonna say that.
I will think about it next time.